So hello students, we are going to start the hybridization calculation. So many of the students were asking that how to calculate the hybridization. So here's a video and there are two methods and we will going to study each of them in a shortcut manner, but it is very important to study. So I hope you have studied what is hybridization. So here there is a formula method. Formula. Okay, what is the formula? So we can write it as steric number, or we write it here as z is equal to, see properly, is equals to half number of valence electron on central Ca is the central atom plus negative charge minus positive charge plus number of monovalent atom. Okay, please note this formula. It is steric number, or Z, is equals to half number of valence electrons on central atom plus plus negative charge minus positive charge plus number of monovalent atoms. So over here I will write. So it is don't confuse this with steric and hindrance that we will study in organic. So now if the Z value comes as 2, then you have to write it as SP. SP it is, if it is 3, then it is SP2, 4, SP3, 5, SP3, D, 6, SP3, D2, and last is 7, SP3, D3. So over here, that is the way how to calculate the hybridization. Let's take two examples of this. So this formula I am writing over here itself. I hope you can see this part. So the first question is which question we can take? It's okay, BF3. This is a famous question and it's an example of an electrophile. And so if there is a dash over here, why I have made a dash over here? Because if you draw the structure of BF3, it comes like this. So if I want to find the hybridization, I first have to know which is the central atom. So this is B, is the central atom. So half, let's apply the formula over here. Half number of valence electrons on B. So valence, tell me the configuration. What is the configuration? 2, 3. So valence electrons are 3. So I am writing it over 3. And there is negative charge, positive. So there is no negative charge or no positive charge. So how many number of monovalent atoms are there? Monovalent means the fluorine's valency is -1, so it is a monovalent. So now there are 3 fluorine atoms, so we will write it over 3. So what will come? 3. So 3, now check to the list. There are 3. When Z is equals to 3, it comes SP2. So you can directly write the hybridization is SP2 over here, and shape is trigonal planar. So this was the first example. Now let us see the second example. We will take a little complex one. PCl5. So how to go about this? So first, same way, identify the central atom. So if I draw the structure, it is a TPB kind of thing because a trigonal bipyramidal, and you can check the playlist of this because hybridization was covered very months earlier. So this is how the calculation, because calculations is asked in CBSE papers. And so this I got the central atom is this. So apply it fast. So valence, it is from group 15, so 5 plus here how many are there? 5. So 5. So you can know that chlorine is also monovalent, so 5 is coming. So 5 recall from the chart which I gave, that 5 is for sp3d. So this was the formula method. I hope you got this method, and this is very essential to apply, and it's important. So formula method is finished. Another method is not the method, but it's a kind of semi method, because like we have to just see the bond pair. Just we have to see the bond pair plus the lone pair, I guess. To just see this. So in most lone pair, or we can see the unpaired also. Unpaired most in nitrogen वगैरह, nitrogen oxide, NO2, and that we have to see the unpaired also. For odd electron species. So unpaired, what is this? Bond pair plus lone pair plus unpaired is equals to Z. We can directly see, because suppose there is an organic compound given to you, which is that given is so this organic compound is given to you. So what is its name? Yes, it is very easy, ethane. So I write here alpha and I write here beta. So if I want to calculate the hybridization of C alpha, so what can I do? I can count the bond pair. How many bonds are there? 1, 2, 3, 4. So 4 bond pairs are there. So if here the Z is equals to 4, so you have to recall. So it will come as sp3. So alpha, C alpha comes as sp3. If you want to calculate C beta, so 1 bond pair, 2 bond pair, 3, 4. So C beta will also come. sp3. Another example is that if I want let's take a complex one. So here many of the students will do a mistake, that they will count the pi bond, but here I am writing bond pair sigma bond only. This is the main part of this. So how many sigma bonds are there? See, 1, 2. I hope that after the sigma bond there are 2 pi bonds. That is also covered, sigma and pi bond. And so this if I write here alpha, so C alpha will be 2. So 2 is what? It will be sp. And if I want to calculate of C beta, that is also 2. So that is also sp. So I will revise this, because this is very complicated, and many of the students will find this difficult. So what? Bond pair plus lone pair plus unpaired, but the bond pair will be with the bond only, that will be the sigma bond, and here all the bonds are sigma. So I took 1, 2, 3, 4. If the Z is 4, then it is sp3, and so C alpha and C beta will come as sp3. And this is the complex problem in which students will get confused, but I had made it clear that I will write it over here, no pi bond. Or students can ask, sir, delta bond. No, sir, delta bond is not in your scope now. So these were the 2 methods of hybridization calculation. I hope you enjoyed the video.